In this video, we're going to go over a quick review of radicals, or what you might know as roots, specifically square roots. So let's say we have the value a. If we were to take the square root of a, that would be the value x. And we know this, or this is true, if x squared is equal to a. So a square root is just answering the question, what number must you square in order to get the value a? So let's illustrate this a little bit more concretely. Let's say we were to have the value 25. Well, what's the square root of 25? You may already know the answer. The square root is 5. And why? Because if you take the number 5 and you square it, 5 times 5 equals 25. So a square root is an answer to the question, what number must you square in order to get the number underneath the radical sign or the square root sign? Now, let's say we were to ask the question a different way, or I should say, let's say we were to answer the question a different way. What's the square root of 25? Well, we already know the answer is 5, but I submit to you that the answer could also be -5. And why? Because it fits the definition. Because -5 squared, or multiplied by itself, -5 times -5 is 25. Now, why is this? Or what does this mean? So now we can say that the square root of 25 equals 5, or it equals -5. Well, what do we do with these two answers? Well, 5 is what we call the principal root. The principal root. You can think of it as the positive root because the principal root is always positive. So 5 is going to be the principal root, whereas -5 is going to be the negative root. The negative root. And all square roots have these two answers. They have the principal root and the negative root. And if you try and find a square root on your calculator, it'll only ever give you the principal root. But the calculator doesn't give you the whole story. Along with the principal root is also the negative root. So if you type in square root of 25 into your calculator, it'll spit out 5. But you must also know that there's a second answer, -5. All right, let's go over another important part of radicals or square roots, perfect squares. Perfect squares. And perfect squares, a perfect square is just when you take any integer and you square it. So let's take the integer 1, and if we square 1, 1 times 1 is 1. Let's take the next integer 2. All right, we square 2 and we get 4. Square 3 and we get 9. And the numbers 1, 4, and 9 are perfect squares because we squared these. They're just an integer square. So I'm going to go ahead and write out the perfect squares from 1 to 100. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And finally, 10 squared is an even 100. All right, now why are these important? They're important for two reasons. Number one, you're going to be using them a lot when you try and simplify radicals. Because in order to simplify a radical, we need to find a perfect square. But another thing you should know is that the square root of a perfect square has a special property. So let's take the square root of one of these perfect squares. Let's take the square root of 36. Well, we know that that equals 6. And let's take the square root of another perfect square, 64. We know that that equals 8. Now, both 6 and 8 are what we call rational numbers. Rational numbers, which means we can represent their value as a ratio of two integers, or in this case 6 over 1 and 8 over 1, but we can write down their value. We can write them as a fraction, basically. However, there are other kinds of values called irrational numbers, and if you try and take a square root of an integer that is not a perfect square, let's say the square root of 2, well, the square root of 2 comes out to be 1.4142135, and I'm going to stop there, but this number keeps on going, and it keeps on going until forever. It doesn't stop until it's infinitely long, and not only that, but it doesn't have a pattern. This number, this value, cannot be represented as a fraction. Therefore, it is this number, and also this number, square root 2, they're the same number, they are irrational. I shouldn't say they're the same number. They are irrational, or it is an irrational number. It cannot be written down. And so the best we can do is approximate its value by rounding to whatever digit we need based on our level of precision, or we can just keep it as a square root, or as what we call a radical expression, an expression that includes a radical sign, the square root sign. All right, so now let's work with some radicals. Let's see, where would they appear in mathematics? So let's say we have 2 points. Let's say this point and this point. And we want to find the distance between these 2 points. Now let's call this distance C. And I'll show you why it's C in a second. Maybe we should call it D, but right now we're going to call it C. And these 2 points can be considered a part of a right triangle. Any distance can be a part of a right triangle, and it's a very special part of the right triangle. It is the hypotenuse of this imaginary right triangle. And we know that, let's say we know that the vertical space between point 1 and point 2, let's call it point 1 and point 2, the vertical space between point 1 and point 2 is 3 units, and the horizontal distance is 4 units. And we want to find the distance between point 1 and point 2, or the length of the hypotenuse. Well, we can use the Pythagorean theorem. And the Pythagorean theorem, if you recall, is just a squared plus b squared equals c squared. And this occurs so much in mathematics, it behooves you to memorize this, know it, love it, and be familiar with it, because you're going to be using it a lot in your future studies. So, if you recall, the A in the Pythagorean theorems and the B stand for the lengths of the 2 legs of the right triangle, and C represents the length of the hypotenuse. And if you square the 2 legs and you take their sum, that equals the square of the hypotenuse. So let's do that now. Let's take 3 and we're going to square it. We're going to add that to 4 and we're going to square it, and that will give us the hypotenuse squared, or the distance between points 1 and point 2. 3 squared is just 9, 4 squared is 16, and so that sum is going to equal the hypotenuse squared. 9 and 16 is just 25, so 25 is the hypotenuse squared. Now we're going to take the square root of the right side, so we're going to take the square root of the left side, and then we're going to simplify both sides of the equation. The square root of c squared is just c, and the square root of 25 is just 5. However, you might say, but now wait a second, isn't it plus or minus 5? And that sign means plus or minus. There's a positive and a negative 5 as a possible solution. And you'd be absolutely right. The square root of 25 is positive and negative 5, or you could say positive or negative 5. So which one of these 2 answers makes sense here? Well, since a distance can't be negative, we ignore the negative root and we just take the positive root as being the meaningful answer. So we can say that the length of the hypotenuse, or the distance between points 1 and point 2, is 5 units. So that is one way we can use radical expressions to find a meaningful answer. So let's take a different situation. Let's say we've got 2 points again. 2 points in space, point 1 and point 2. And we want to find the distance between these 2 points. Well, we know that this is just a part of some imaginary triangle, imaginary right triangle. And if we know points 1 and point 2, then we can determine the vertical and the horizontal distance. Now let's say the vertical distance is 3 and the horizontal distance is 5. Well, we can use the same Pythagorean theorem to find the distance between points 1 and 2, or the length of the hypotenuse. So that's a squared plus b squared equals c squared. And what we have is a squared is just going to be 3 squared plus b squared, which is 5 squared. And that leaves us with, or that is equal to c squared. 3 squared is 9, 5 squared is 25, and 9 and 25 is 34. That leaves us with 34 equals c squared. So if we want to find, we don't care about what c squared, we want to know what c is. So we're going to take the square root of c squared, which gives us c. But what is the square root of 34? Well, 34 is not a perfect square. And we know that if we take the square root of an integer that's not a perfect square, we're going to end up with an irrational number. And surely enough, if you put this in your calculator, you end up with the number 5.83095, and I'll stop there, but it goes off into infinity, and there's no pattern. So we have two options here. We could represent the answer imprecisely as a decimal with a finite number of decimal places, or we could be very precise and just represent this irrational number as a radical expression, the square root of 34. And so our answer is the square root of 34. Now, this may seem uncomfortable because you might feel, well, but that's not the answer. What's the actual number? Well, you have to understand that the square root of 34 is a number. It's an irrational number. It may not be a number that or the kind of number that you're used to using, but it is a number on the number line. If it's 5.8 something, you can imagine a number line like this where you've got, 0 here, then 1, 2, 3, 4, 5, 6. All right, 1, 2, 3, 4, 5, and 6. And so this number, although we can't write it down, is somewhere around there. Right there is the square root of 34. It exists on the number line. We can't write it out in decimal form because the decimals will go on forever, but we can represent its value as a radical expression, the square root of 34.